Good morning, children. Let us continue the science class now. Already you have learned about motion, force and then missions. So we are on the missions now. And already you have learned about levers, first order lever, second order lever and third order lever based on the effort, fulcrum and the load, isn't it? Now let us go for the next one, that is called as a pulley. Then what is a pulley? A pulley is a grooved wheel with a rope. It is a grooved wheel with a rope, belt or chain wrapped around it. It can be fixed or movable. A pulley is actually a variation of a lever. It is circular lever that rotates around its fulcrum. I will be showing you later. A pulley that is attached to a structure is called a fixed pulley. You can see here. This one. So this is a flagpole and here you can see a wheel. Okay. So that wheel is fixed to this pole here. Okay. And it has got a groove wherein you can see the rope is passed on through that. There is a rope which is passed on. So especially for flag hoisting, that is during national festivals and all that, we use this flagpole, isn't it? So for that this pulley is there and this pulley has got a groove through which the rope is passed and that pulley is fixed to this pole, flagpole. So a pulley that is attached to a structure is called a fixed pulley. It is attached there. So it is called as fixed pulley. The wheel of a fixed pulley moves. So what happens here? This wheel will start moving, but not the flagpole. Okay. The wheel of a fixed pulley moves, but the pulley doesn't move by itself. It will not move by itself until and unless you apply force on it. The distance where we apply the effort is the same as the distance through which the load moves. Now for example, now flag is the load. Got it? So flag is tied to this rope, isn't it? Now you see this. If you just start pulling this rope, when you pull the backside rope, what will happen? This the rope which is tied for flag will move up. This rope, the backside rope will be moving down. Then what happens to this rope? As this comes down, this will move up. Now when you want to bring the flag down, what will you do? You will start pulling this rope. That time what is happening to this rope, backside rope? That will move up. When this flag is coming down, this rope will move up. When this rope is coming down, backside rope is coming down, this rope will be moving up. That is the meaning here. How much ever you put the effort and bring the distance, the same distance will be followed on both front as well as back. That's the meaning here. The distance where we apply the effort means you are using a hand to either pull or push. Understood? That is called as effort. So the distance where we apply the effort is same as the distance through which the load moves. So this distance, how much the rope comes down, that much distance rope will go up. How much ever this rope comes down, that much distance this rope will go up. Okay, so through which the load moves. When we pull down the rope, the load moves up, isn't it? When you are pulling down the rope, what happens? The load is moving up. An example of a fixed pulley is the top of a flagpole. A person standing on the ground can raise the flag to the top of the pole and lower it to the ground due to the fixed pulley. So how is it possible for this man to make the flag move up? How? Because there is a pulley here, there is a groove, rope is tied to that, and when he brings this rope down, this flag is going up, isn't it? So what happens? There is a fixed pulley. I will show it here. See, this is a flagpole. You can see the flagpole here. Can you see this? See, this is a wheel. See here. Okay. And this is having a groove. You can see that groove. That means you can see there is an opening here. You can see the opening here. Okay. And through this, the rope is passed. Okay. So this is fixed. This pulley is fixed to this pole. You can see this. Okay. Yes. So a movable the pulley is attached to the object, we are moving. One end of the rope is attached to a fixed structure overhead, while the other end of the rope goes down through the pulley attached to the load and then back up to the top. Pulling the other end of the rope causes the load to move up. You would have seen drawing water from the well. What they do when they want to draw water from the well, 1 minute. Now you can see here, children. Look here. This is how it will be. Okay. So this side the person will be standing where just on the bank of this well, this side, and the other side the well is there with the water. So what happens? That side rope, the bucket or the pot will be tied. Okay. So this man, as what he does, he goes on releasing this. When he releases, what happens? This pulley will be moving and the bucket will go into the water. The bucket will go into the water. Understood? And once the water is filled in the bucket, what happens? He will start pulling from this side. When he pulls from this side, what is going to happen? The bucket from that side, the filled bucket from that side from the well will come up. So here the rope is moved down, but that side the rope is coming up with the bucket. And then finally he will be removing it. Did you understand? So this is about the pulley. This is not fixed. You see, here it is moving. You can see the wheels are moving here. Did you understand? So this you can see that it is moving. Got it? See. See like this. Okay. So that's about the pulley here. Now, the movable pulley does not change the direction of the effort. So movable pulley, you can see it is a movable pulley. What happens? It will not change the direction of the effort. Effort means you are putting the effort, it's not going to change. Because I told you now, if you have to draw the water, what you have to do, you have to stand on the bank only. You cannot be inside the water, isn't it? So from there you cannot change the direction. The load is supported by the rope on both the sides of the pulley, which means that half the effort is needed to lift the load. See here, what is given here? The load is supported by the rope on both the sides, is it not? So the load is what? You are tying that bucket or pot, isn't it, to fill water. That is the load. Clear? So the load is supported by the rope on both the sides. I told you either side. That side also rope will be there. This side also rope will be there. This side rope will be in your hand. That is effort. And that side rope is tied with the bucket. So that is called as the load. Okay. Now, which means that half the effort is needed to lift the load. And why? Because there is pulley, you don't have to put more efforts. If pulley was not there, we had to directly draw water from the well, isn't it? That will requires more and more effort. That means more energy. But wherein here what has happened? Because there is pulley will easily rotate. So it is easy for you to remove the, what is that? To carry the load. The force needed to move an object is less, but the distance through which the force must move is longer. So here what is happening? The force means the energy what you are using is needed to move an object is less. Why? Because there is support of pulley. If that pulley was not there, you have to use more force or more energy. But now, because there is pulley, what is happening? It is easy for you to draw water. So, but the distance through which the force must move is longer. So, but the distance what is happening? It is becoming longer because it has to go up, go through the pulley and come down. Isn't it? If it was directly from you means the distance will be less. But now it is going up and coming down. So, that much distance is becoming more. That's the meaning here. So, you can see here. Understood? So, movable pulley. See, movable pulley. From this is the load and this is moving. See? So, this side you have to pull it. Okay, then this load will come up. Clear? But the distance is the same. Both the sides, the distance will be the same. But the force what you are applying will be less, whereas the distance will be more. Is it clear now? Okay. Now, next let us go for wheel and axle. A wheel and axle is a simple machine made up of two circular objects of different size. The axle is nothing but a small rod. Is attached to the center of a large wheel. All wheels require an axle. The wheel and axle must move together to be a simple mission. Effort applied to the wheel turns the axle and vice versa. So what happens? The wheel as well as rod both will be moving. Otherwise movement cannot take place. So that is called as both the missions are moving together or vice versa. That means outside wheel and inside rod both has to move. When effort is applied to the wheel and axle spread the force over a greater distance. If the radius of the wheel is 2 times larger than the axle, the force will be multiplied by 2 every time the wheel is turned. A wheel and axle can produce a gain in either effort or distance depending upon how it is used. Now, example they given here: door knobs, roller skates, gears and handles of a tap are all examples of a wheel and axle. So here you can see. So faucet means tap, you can see. When this tap here, what happens? There is a knob. Can you see the knob here? When that knob rotates, what is happening? Inside there is a thread, that rotates on the opposite direction. Then what happens? Water comes here. Clear? Door knobs. So the handle, when you just rotate the handle, what is happening? It gets opened or closed. And this is roller skates and then gears. Okay? So you can see here, I will show you. Now, this is a roller skater. Roller skates you can see here. What is this? This is a wheel. What is this? This is a rod. So when the wheel is moving here, inside what happens? There will be ball bearings. And the ball bearings, if this is moving here, ball bearings will be moving to the opposite direction. But this is giving a support for this wheel to move. Did you understand? So this is wheel and this is called axle. This is axle. The support one is called axle. This is wheel. But inside there will be ball bearing. So what happens? That moves. Okay. Which will make it to move. Which will make the wheels to move. So this is about the wheel and axle. So here what is happening? Because here the wheels are moving on the inside, there will be ball bearings. It is easy. Otherwise what would have happened? There would have been more friction caused. So you can see here. So this is one more you can see. See here. Can you see? So what is this? This is axle and this is wheel. So wheel and axle. Can you see? So when it moves like this, you can see the ball bearings which is formed inside, that will be moving in the opposite direction. So which will make the work easier. So it helps in rotation. So this is about wheel and axle. Now, yes, now you can see here children. Yes. So you can see here the flagpole and here is you have seen the pulley, and this pulley will have a groove, and through that groove what is passed on? You can see the rope is passed on. So one side of the rope is tied to the flag which is called as load, and the other side is fixed to the flag pole. Okay. So here this person is going to pull the rope. What is happening? The load will, he is pulling the backside rope. What happens? Then this load means the flag is going up. Okay, and finally he is going to tie it here. Did you understand? So that is about the pulley here. And here already I have shown you this also. So you can see the pulley. Here load means, now for example you can take bucket of water from the well. And here you are standing and you are going to pull it. Pull that water. So when you pull here, what happens? Here you are putting the efforts. So this is going to be the fulcrum here. So that is the support. So when you put effort, what is happening? When you are pulling this rope on the either side, here other side, here what happens? This bucket of water also will be moving up. Did you understand? And then when it comes to the distance where he can take the bucket out, he will stop it there and he will take the bucket out from the well. Did you understand? But what happens if he is taking directly from the well? He had to use more force. The distance would have been less. But now what happened? He is standing here and through the help of pulley he is taking it. What happens? The force applied will be less. But the distance will be more. Did you understand? So that is about the pulley. Wheel and axle. Yes. Now you see wheel and axle. It's a simple machine. So here you can see what is there? There is you can see what is this? A knob-like structure which will rotate. It will rotate. Okay. So when you go on rotating, that means you are applying force there. When you apply force, it is rotating. What will happen to this? So here see there is a connection. That rod is called as the axle. And this which is helping it to move, that is called as the wheel. Okay, wheel. Here axle. Here you can see the pulley. Clear? Now this is the bucket. You can see only the hand of that. That is the load bucket. Got it? This is the well. So what is he doing? When he goes on, just applying force to this wheel, it will rotate and it will release this rope, and the bucket goes down into the water. After filling, again what he does? He rotates it. When he rotates, what will happen? This will again start whirling to the pulley and the bucket comes up. Got it? So this is about the wheel, and here axle, and this is the pulley. Okay, now let us go for the next one, that is inclined plane. An inclined plane is a flat surface set at an angle other than right angle against a horizontal surface. It is a simple mission without any moving parts. An inclined plane enables us to overcome a large resistance by applying a relatively small force through a distance from the load to be raised. As the slant of an inclined plane decreases, it takes less force to raise the load, but the load must move through a greater distance. The steeper the slant, the greater is the force required to raise the load. You can see here. So this is an inclined plane. Okay? See, this is an inclined plane. Normally you would have seen if this coolies, when they want to load rice, wheat, all that sacks, into the lorry, what they do? Directly they cannot climb into the lorry. What they do? They just keep a slanting plank. Isn't it? They keep a plank and then they carry the load. You would have seen. They carry the load and then they climb up the plank and go and put it into the lorries. Have you understood? So that is about the inclined plane. It will be like this, so that it will be easy for them to carry the load. Did you understand? And here you can see this. Look here. So this is the inclined plane. Bottom base is horizontal to the ground. Okay. But upper part there will be a slope. It will not be at right angles. But as it goes more and more slanting, if it's more slanting, what happens? They have to use more efforts. More force has to be applied. But if it is little sloping, not more sloping, if it's little sloping, what happens? The force applied will be less. So you can see here. Now this is the load. So this is the load. The load has to move up. Like this, it has to move up. Understood? So it will be easy. Got it? See? Like this. The load has to go up. So this is about the inclined plane. So once again, I'll just read it for you. An inclined plane is a flat surface set at an angle against a horizontal surface. There is an angle, but it is against a horizontal surface. It is a simple mission without any moving parts, no moving parts there. An inclined plane enables us to overcome a large resistance by applying a relatively small force through a distance from the load to be raised. The load has to be raised. So you can see the person here. Okay, he has to move this up. So directly if there were steps, what would have happened? It would have been very difficult for him to move. Because he has to avoid that and the work has to be done. What is happening? there is a slopey area, you can see here. Okay. Now, as the slant of an inclined plane decreases, the slant of this is decreasing, it takes less force to raise the load. But the load must move through a greater distance. But it takes more distance. The steeper the slant, steeper means, now for example, this slope would have come here like this it had come. Then what would have happened? The steeper the slant, the greater is the force required to raise the load. If the steep was like this, then he had to put more effort and then carry that load, isn't it? So that is about the inclined plane. Okay, now here you see. This is what I said. So this is a lorry, actually, the back of the lorry. What he has to do? He has to put this, maybe a load into this lorry. What is he doing? See, he is climbing through this inclined plane. If there were steps or a direct, if he has to climb, it is very difficult. So he has put that plank here. You can see. And through that plank, he is carrying that load and putting it into the lorry. So let me stop it here, children. We'll continue in the next class.